Hello friends, this video on application of derivatives part 3 is brought to you by examfear.com. No more fear from exam. Before watching this video, please make sure that you have watched part 1 to part 2. Let's take one more example. Let's take one more question. The question says the radius of a circle is increasing uniformly at the rate of 3 centimeter per second. So the radius is increasing at rate of 3 centimeter per second. We define at which the area of the circle is increasing when radius is 10 centimeter. So let's draw a circle. So if this is R, let's suppose if this is R, the question says the radius is increasing. It is increasing like this. Since it is increasing, the circle is also increasing. If you see, the circle will expand. Why? Because the radius has increased. The radius will increase all the more, the circle will expand all the more. And thus the area will also increase for the circle. So the question says the radius of the circle with respect to time, that is change of radius of circle with respect to time, that is dr by dt, is nothing but 3 centimeter per second. This is given. And what we are asked to find? We have to find change of area of circle with respect to time, right, where radius is 10 centimeter. This is what we have to find. Make it small r because I'm taking small r everywhere. So dr by dt is 3 centimeter. We have to find d area by dt. So let's try to do this. Area is nothing but pi r square. So this is nothing but d of pi r square by dr, where r is equal to 10. This is nothing but pi into r square became 2r, and that's all. There is no dr by dr here because I am differentiating r with respect to r only. And this, sorry, I have to find dA by dt, correct? Since it is dt, here dr by dt component will come. Why? I'll tell you why. I wrongly took as dr. If it is dr, see, d of pi r square by dr will be 2 pi r, correct? But d of pi r square by dt will be 2 pi r dr by dt. Good that I made a mistake so that you can understand the difference here. So if you are differentiating r with r, there is no dr by dr component. But if you are differentiating r with t, then you get dr by dt component. So this is what we get. Correct? So dr by dt is something which is unknown to us. What should we do? We can use this formula. dr by dt is nothing but 3. Correct? And r is 10. So let's put the value pi into 2 into r, that is 10, into dr by dt, that is 3. Correct? So this becomes 60 pi. What will be the unit? I'm talking about change of area with respect to time. So this is nothing but, and this is centimeter. So this is nothing but centimeter square per second. Correct? Why it is like this? Because I'm talking about change of area with respect to second time. So it is centimeter square per second. Please note the unit is very much important to understand also. So the question is, you have a circle of radius r, the radius is increasing, the area is also increasing. Rate of change of radius with respect to time, that is dr by dt, is given, and we are asked to find rate of change of area with respect to time. If we did that, we just replace the area formula with pi r square, and we solve this to get this value as 2 pi r dr by dt. I know the value of r is equal to 10. I know the value of dr by dt given 3. Put all the values, I got 60 pi, and then I found the unit. Unit came out to be 6 centimeter square per second, because I'm talking about change of area. This is area with respect to time. This is second. Correct? Let's take one more example. An edge of a variable cube is increasing at the rate of 3 centimeter per second. We have to find how fast is the volume of the cube increasing, where edge has a length. So let's assume this is my cube, correct? And let's assume the length is all L. Now this length is increasing. Everywhere length is increasing actually, right? So the new cube we should get will be something like this, I think. If I'm correct, you'll get something like this, the new cube. Everywhere it will increase actually. This is the new cube, correct? Yeah, this is the new cube. If my length is increasing in this direction. So the question says, if you see the edge of the variable cube, the cube is variable, is increasing at this rate. So dl by dt, because the edge, change of edge with respect to time, you see it is per second, correct? So it is dl by dt. Why it is dl by dt? Because it is centimeter per second. It is increasing at the rate of this. So dl by dt is nothing but 3. This is given. We have to find how fast is the volume increasing. That is, I have to find dv by dt, where L is equal to 10 centimeter. This is what we have to find. Now we know the formula of V is nothing but L cube, simple. So we can rewrite this as nothing but d of L cube by dt. This is nothing but 3L square into dl by dt, where L is equal to 10. Let's put the values here. 3 into L square, that is 3 square. Sorry, 10 square, because L is 10 here. 3 into 10 square into dl by dt, that is 3. This is nothing but 900. What is the unit? Change in volume by time, that is centimeter cube. Volume by time, that is second. So 900 centimeter cube per second is the answer for this. So this was a simple question where I was told that the edge of a cube is increasing at the rate of 3 centimeter per second. So it is plus 3 dl by dt centimeter per second. Volume I know is L cube. I have to find dv by dt. I have to find how fast. If you see, fast and slow is all time dependent. So I have to find dv by dt. And that's what I have found. V is equal to L cube I put. I got equation in terms of L and dl by dt. I know the value of L. I know value of dl by dt. Put the value and get the answer. Very simple. Let's take one more example of rate of change of quantities. A stone is dropped in a quiet lake and a wave moves in a circle at a speed of 5 centimeter per second. At instant when radius of the circular wave is 8 centimeter, we have to find how fast is the area changing. So let's visualize this. This is a pond and somebody has dropped a stone here. The moment a stone is dropped, you see the wave like this. Correct? So you drop a stone from here and you see the wave like this. And wave, if you see, is nothing but a circle. This is a circle, this again a circle. So it's all circular shape. So what you see, it says that it creates a circle which moves at the rate of 5 centimeter per second. 5 centimeter per second. So if you see, this is nothing but length and this is time. So I can say that from this that dr by dt is nothing but 5. Now if the radius change, if you see, what I'm saying is rate of flow of wave is nothing but rate of change of radius with respect to time. If you see, the radius was, let's suppose here, this guy r. This became, this is delta r, let's suppose, right? Because the radius is increasing. So the increase in radius with time is nothing but wave speed. Correct? The question says that the speed of the wave that moves in circle is 5 centimeter per second, and that is nothing but dr by dt. That is change of radius with respect to time, because the wave moves in this direction and the radius also increases in this direction. That is the critical part here to understand. If you understand this part, the question is simple. Now that we know, the question is how fast is the enclosing area increasing. That is, the question is asking us to find change of area with respect to time. Area is nothing but pi r square, that is d of pi r square by dt. Correct? And we have to find this when the radius is 8 centimeters. So this is nothing but r is equal to 8. So if you differentiate this guy, this is nothing but 2 pi r dr by dt, where r is equal to, now let's put the value, 2 pi r is 8 given, into dr by dt is 5 we know. So this becomes 80 pi, and this is change of area with respect to time, and this is centimeter. So this is centimeter square per second. Thank you. Visit examfear.com to watch free educational videos, try free online tests, get the best quality study materials, study from the best tutors and mentors, and much more. Thanks once again.